Hello everyone. So today we shall see about another important topic in mathematics. There are two things which are like building bricks of mathematics. One is called set and another one is called functions. About sets we have already discussed. So now we are getting into functions. Function. See, what is called function? My very first statement is, we have already learned about relation. So from that I will take the definition of function. See, every function is a relation, but every relation need not to be a function. Let me repeat. Every function will be a relation, but every relation need not to be a function. See, function means you can think it of as like this, See, there is something called, there is some mission, say that mission I call it as f or f of x something, okay. See, in this mission I am giving some input. So, whatever input I give, that should give me an output. This is the first condition for a function. There is some mission, I am giving some input. If I give something, that should give me as output something, okay. This is the first condition. The second condition is, whatever input I give, that should give me a unique output. In the sense, if I give one object inside this mission, that should give only one object as output. If I give one object inside the mission and if it gives two objects as output, then it fails to hold the definition of function. Okay, so only there are two conditions for a function, which mean if you give any input, that should give an output. The second condition is if you give one input, that should give you only one output. So we simply say it as every element of domain should give a unique image in codomain. What is domain and codomain? Nothing, very simple. A function from where it starts, that set is called domain, and the function where it ends up, that is called codomain. Okay, so the mission f of x takes the elements from a to b. So this is domain and this is codomain. Okay, but my first statement was every relation need not to be a function, but every function is a relation. So how we can understand this? So we shall look at about that now. For example, this is my 1, 2, 3 and say A and B. This is my A and this is my B. So we know very well about relations. Okay, let me tell you about function. See, my 1 has output A and 2 has output, 2 may also have output as A and 3 has output B. Now check the definition. Here there are 3 people in the domain, right? For every input, these are the elements I am going to give as an input to my mission f. Okay, so 1 has, if I give 1, this f takes my 1 to A. If I give 2 as an input to my f of x, this my f takes my 2 to A. If I give 3 as an input, my f takes my 3 to B. Check the definition. What is our definition? Every input should have output. Yes, only there are 3 elements in an input set. For each input there is an output. First condition is satisfied. What is the second condition? For every element there should be a unique output, which means for I give 1 inside f of x, that gave me only A as output. I give 2 as an input to f of x, that gave me A as output. I give 3 as an input and my f of x gave me B as output. That's all. For each single input, that gave me a single output. So every element in domain has a unique image in codomain. What do we mean by image? For example, 1 is the input, f of 1 is the output. What is f of 1? F of 1 is equal to A. So then I can say A is the image of 1 under f. 1 is here, A is here, f takes my 1 to A. So I can say this A is the image of 1 under f, because f only takes 1 to A. So what about B? I can say B is an image of number 3 which is from domain under F. So B is the image of 3 under F. A is also an image of a number 2 under F. What is called pre-image? I can say 1 is the pre-image of A under F. 2 is also a pre-image of A under F. 3 is a pre-image of B under F. Right? Okay, fine.